Hey everyone, welcome back to the channel. Today we're going to talk about something that powers almost every fast application you use daily, Redis. Have you ever wondered why apps like Instagram, Netflix, or Swiggy feel so fast even when millions of users are online? The answer is often caching, and Redis is one of the most popular caching technologies in the world. In this video, we'll understand Redis in a very practical and intuitive way. No complicated theory, no boring definitions. We'll see why databases become slow, how Redis fixes that, how caching actually works, where Redis shines, and also where you should not use Redis. So by the end of this video, you'll clearly understand why developers love Redis so much. Let's get started. Before understanding Redis, let's first understand the real problem. Imagine your application has to fetch user data from a database every single time someone opens the app. Now, databases usually store data on SSDs or hard disks. Even though SSDs are fast, compared to RAM, they are still much slower. So when traffic increases, the database starts struggling because thousands of repeated queries hit it continuously. This becomes a bottleneck. Now, this is where Redis comes in. Redis stores data directly in memory, inside RAM. Since RAM is extremely fast, Redis can return data almost instantly. So instead of asking the database again and again, your application first checks Redis. If the data's already there, boom, instant response. You can think of Redis like a super fast shortcut. Now let's understand the most common Redis pattern, called cache aside. This is the pattern most real-world applications use. Here's how it works. Suppose a user requests profile data. Step 1. The application first checks Redis. If the data exists there, it's called a cache hit, and Redis immediately returns the response. Super fast. But if the data is not there, that's called a cache miss. Now the application queries the actual database, gets the data, stores it inside Redis with something called a TTL, which means time to live, and then returns the response to the user. So the next request becomes extremely fast. Now, one important thing, usually writes go directly to the database, and then the Redis cache is updated or invalidated afterward. This keeps the cache fresh without making the architecture too complicated. Okay, but here comes the interesting question. How is Redis insanely fast? Like, how can it process more than 1 lakh operations per second? There are mainly 3 reasons. First, Redis stores everything in RAM. No disk access. That alone gives huge speed improvements. Second, Redis uses a single-threaded event loop. Now, beginners often think single-threaded means slow, but actually, this removes thread locking and context switching overhead. So Redis becomes very efficient. Third, Redis uses non-blocking I/O, meaning it can handle multiple network requests very efficiently without waiting for one request to finish before accepting another. All these together make Redis unbelievably fast. A lot of people think Redis is just a simple key value store, but Redis is actually much more powerful. For example, strings can be used for caching text or tokens. Hashes are great for storing objects like user profiles or session data. Sorted sets are extremely popular for leaderboards and gaming apps because Redis automatically keeps items sorted. And Redis also supports streams and pub/sub messaging. This allows applications to build real-time systems like notifications, chat apps, live tracking systems, and event-driven architectures. So Redis is not just a cache anymore. It's almost like a complete high-speed data engine. Now let's talk about one important production concept. Redis stores data in RAM, but RAM is limited and expensive. So what happens when Redis memory becomes full? That's where eviction policies come into play. Redis automatically decides which data should be removed. One popular policy is called volatile LRU. LRU means least recently used. So Redis removes old, unused cache entries first. This is important because without proper eviction policies, your Redis server could run into out-of-memory issues. And trust me, that's not something you want happening in production.
Now, Redis is amazing, but like every technology, it has trade-offs. Let's first see why developers love Redis. It's insanely fast. It supports powerful data structures. And Redis also supports high availability features like replication, sentinel mode, and clustering. But there are downsides too. RAM is expensive compared to disk storage. Also, Redis persistence is often asynchronous, which means in rare crash situations, you could lose some recent writes. And Redis is not designed for complex relational queries like SQL joins. So Redis is not a replacement for traditional databases. Instead, it works best together with them.
So where should you actually use Redis? One of the biggest use cases is session management. Things like login sessions, shopping carts, OTP verification. All these need extremely fast access. Redis is perfect for that. Another major use case is reducing database load. If thousands of users request the same data repeatedly, Redis can act like a protective shield for your database. Redis is also heavily used for rate limiting. For example, preventing spam requests or bot attacks on APIs. Since Redis operations are extremely fast, it can track request counts in real time very efficiently. Now, this part is very important. Many beginners get excited and try to use Redis everywhere. That's a mistake. Redis is not ideal for heavy relational data. If your application depends heavily on joins and complex SQL relationships, traditional databases are much better. Also, if your system cannot tolerate even a tiny chance of data loss, Redis alone may not be the right choice. And finally, using Redis for massive cold storage data is financially impractical because RAM is expensive. Redis should be used strategically for speed-critical workloads. So that's Redis in a nutshell. Today we learned why databases become bottlenecks, how Redis caching works, why Redis is insanely fast, its powerful data structures, and the practical trade-offs you should know before using it. If this video helped you finally understand Redis clearly, drop a comment saying cache hit. And also let me know what topic you want next: Kafka, system design, microservices, or maybe AI infrastructure topics. Don't forget to like, subscribe, and share this video with your developer friends. Thanks for watching, and I'll see you in the next video.